There we go. Episode 85. And yeah, I forgot to count to three. And I saw on Twitter some people thought this started an hour ago, but again, summertime apparently messed up some schedules. So we'll see. Um, we got Loic and where are you? There, Ozan. You guys been on before, I think. But you guys can give we have a packed program, so to speak. So you guys can introduce yourself once you get on. We will talk about what's new in Kafka and how Loic and his team is using Kafka. I think it's the short summary. Um, there's one piece of news I want to share is if you go on Quarkus.io, the blog, there we announced VS Code Quarkus update. So if you use VS Code for your microservices, etc., we've had this tooling for a while. It's in VS Code, it's in IntelliJ, Eclipse. But the VS Code is the one that comes out first. But the new main feature I have there is Qt support. So content assisting Qt, validation in Qt, navigation in Qt, support for templates, all kind of good stuff. So if you are trying out Qt or using Qt, look at the latest blog we have about the VS Code tooling. And sometimes this week, there'll be another blog detailing what's there about the Qt support. So all about Qt in the news today. And as always, if you have questions, put it in the chat, then I'll bump in and ask Ozan and Loic a question. I think that's about it. So Loic, Ozan, I think you were going to start. Maybe do a quick intro yourself, and then you take it from there.
So, I'm Ozan. I'm working at Red Hat on Quarkus and Smallride projects, mostly around Kafka, but other reactive streams, reactive messaging connectors as well. So let's jump into the code. Am I sharing or?
You are in 2 seconds, yes. But you have
okay, nice. Yeah,
there
that's the matrix.
Oh.
Okay. So I want to give you some updates around what has been going on around Kafka and Quarkus. Since the last insight we did, there are some small changes, but some more significant ones that are coming as well. And one of the things that has been a community contribution was the code start for Quarkus. So if you go to the code.quarkus.io, you can actually choose Kafka connector or any small reactive messaging connector, and it will come with a starter code. And that's actually what I'm using right now. I made some changes, but that's the basic project, and it comes with the working stuff that pushes recourse to Kafka and consumes them. And what I did as changes is I added the REST-easy reactive. So I have an emitter that will push messages to Kafka and then consume them in here in a different channel, and have a incoming, like a in-memory channel that will just print out the result. So we will be using reactive messaging. It's a declarative way of consuming and producing events in different kind of messaging backends. We will be mostly talking about Kafka, but there are other protocols, brokers, technologies that are supported, like AMQP, RabbitMQ, JMS, Camel, etc. So one thing that I will be showing. So let me just show you the POM file. I didn't do any changes except that. So I'm using a local build of Quarkus, because later on I will be showing a feature that's not merged yet, but it will be very soon. And I have the REST-easy reactive Jackson and REST-easy reactive, and of course smaller reactive messaging Kafka extensions. And what I already showed you this stuff around consuming and producing Kafka events. And the idea is just receive a payload from REST-easy reactive post and push it into Kafka and consume it, etc., etc. One stuff that has been changing since we did an insight is how we are handling the configuration for Kafka. You can notice, maybe if you have been using it, there's no more need to actually write the messaging connector. Because if you are using just only small Kafka or RabbitMQ or AMQP, etc., you don't need to go ahead and type it. During the build time of Quarkus, we are detecting that there's only one connector, and so this stuff is no longer needed. One other thing is that now, if you are using the serializers, deserializers, and for a quick start, you can start using Jackson, and it will be auto-generated for you. I have a I was just consuming strings, but now I just want to transform it to a Jackson payload, and I can simply write it down in here. In here, of course, I will be consuming a JSON here. And what else? I think that was it. And if I run my app, we will see that without any configuration, we will auto-generate a serializer or a deserializer for you for using Jackson for JSON serialization. Or now, that's one of the cool things that's already always good to mention is the dev service. We don't set up anything. By default, it's on. It had created a Kafka Broker for development purposes that uses Red Panda, which starts really fast and Kafka API compatible broker implementations. So you can see that somewhere in here, so the dev service has started, and actually we have, let's see if I can go back to my dev UI. So the channels are listed, and I can see that the emitter words out channel for my reactive messaging framework has been configured with the value serializer as the generated Jackson. And let's test it out. Yeah, I have here. Hi, Loïc. Oh, yeah. Application JSON. Yes. So actually, it goes to the message goes to Kafka. It turns back. It's consumed and transformed to. It is consumed as a string and transformed to uppercase. So one thing that this is that is on their services, we can actually define. I remember if it was here when we did the last insight, but you can go ahead and start the Kafka Broker with some partitions. That's always a good way to start testing your application with multiple partitions. So at application startup, when the broker starts, it will create the topic with the number of partitions that you want. So if you go ahead and type it, somewhere in here, I guess, or maybe I need to restart the app because the dev service has already been existing. And you will see that there's actually, it's really simple. The admin client starts up and connects to the started broker and creates the topic with partitions. Yeah, somewhere in the log it says the topic is created with 3 partitions. And actually, the next thing that I want to talk about is a bit in depth, but we have been changing how the messages are dispatched with the vertex context. But it has also a small feature that can be used, which is context locals. So now we are making sure that every message, every method in reactive messaging is dispatched on a vertex context if it exists. So in Quarkus, every threading is on vertex context. So we can actually use something like context locals, which is kind of the same idea of thread locals, but it's bound to a vertex context instead of thread context. So I can go ahead and say, let me see.
When you say kind of, you mean it's like it'll be in the same sequence of invocations, right?
Exactly. It's not bound to a thread, but it's bound to a sequence of operation stream, let's say. I'm going to write down the, so in here, there's an incoming and outgoing channel. So the outgoing channel will be consumed in here in a separate method. So I will be taking out the partition info from here and consuming it here. To do that, I need to change this stuff from Kafka to generic message to Kafka record. And let's call it record in here. And so this will maybe not, because I do lots of changes. So I'll do get partition in here, and then consume in here partitions, maybe a default value of -1, and maybe it in here partition. So it will print out in which partition the message was coming from. Oh, my Quarkus is already up. So if I go ahead and do another call, it will reload, and the message is coming from partition 1. Again, it has been written to partition 2 for the second message. So it's a way to share maybe like some, let's say, a custom information that you want to put in your execution, but not really maybe business oriented. You can pass information like that during your execution. And let's see what on the list afterwards. Oh yeah. So we have been doing some. We have been developing a different API for consuming and producing Kafka messages. We know that writing, creating the Kafka consumer and producer by hand is very annoying. And it's mostly destined to the tests. So now I have a test that's doing pretty much nothing. And it just sends hello. Let me fix that first, right? Yeah. And now I just want to test in the app that my post call actually sends the message, and I can validate by consuming from Kafka topic that it has been sent. So we added a Quarkus test resource, which is a way in Quarkus test to add into your test lifecycle different resources that you can start with your test suite. What was it? Companion resource. So that will if the dev service is activated during the tests, it will use the dev service. If not, it will create a Kafka broker for your application, for your test suite that will use string-z test container. So I can go ahead and inject a Kafka companion. That's the new API that we have written to interact with Kafka. Companion. So now, after I've been giving a post, I can go ahead and consume strings from topic. My topic is birds. I actually want only one. Await completion of my consumption, and then get the last record that I consumed, and maybe assert that it contains what I want. Words dot contains value contains. Let's see if that works. So that will actually create a consumer for a limited amount of time. It will subscribe the consumer to the words topic, consume only one record from that, and actually gather the records, and then we can assert some stuff on that. So
what was the new thing? I missed that.
So new thing is this API. That's the Kafka companion resource, the Quarkus test resource, and the Kafka companion API that lets you write, consume, and produce some records to the Kafka.
Yeah.
Let me see what's going on. That's a lot of messages. Oh, okay.
So while you're fixing there, what version is this available in? Is Matt Stramel?
2.8, I think. So okay, that's so the one. Yeah. I actually don't know what's happening here. So it will be. Let's restart that. Right, that is a configuration stuff. So the post will be sent to hello. No, demo effect. Anyways, another thing that that's not still merged, but that's the last thing that I will be talking about, I think, is the transaction API for Kafka. So it has been long coming, and we don't know how to integrate it into reactive messaging. But now I think we have a way that can have some sense on how we are using it. So instead of using the emitter API, mutiny emitter on the normal one, now Kafka connector proposes a Kafka transactions emitter. It is still a normal kind of emitter, but it comes with a new API that will let you emit some records on inside a transaction. So you can go ahead and maybe send the same message 4 times, and the API expects that you return with a uni that will be returned after the transaction is complete. So if the transaction fails, it will return a uni with a failing result. And for me to use it, I actually need to configure my Kafka producer with a transactional ID and X to all. transactional ID. Let's call it producer. And I also need to say that. So the thing is, the Red Panda Kafka Broker, Kafka API compatible broker that we are using by default doesn't really support the transactions. It can be enabled. I can go ahead and do that. Quarkus Kafka Dev Services transaction enabled true. So that way, normally you will see that. Yeah. See if maybe I need to restart my app, because it should start the broker with a flag that will enable the transactions API on Red Panda. And I'll run this again. So now it's just sent the same message 4 times inside the same transaction. And if for it to make sense, I actually need to also say that my consumer also consuming it in consuming the records that are committed and not all the records that are sent. So I did that I'm consuming also only the records that are committed inside the transaction. And let me see if that will refresh. Yeah. And actually, if I say that, let's say after my second sent event, if equals message.name, if something happens during the transaction, you'll see that the first 2 messages that were already sent won't be committed. Let's see. Okay.
You have all the luck today.
No, it's actually normal, because I sent a payload with the name Ozan, and it actually says that the transaction failed and it didn't send anything to the. Actually, the messages were sent, but the transaction wasn't committed.
By the way, since you're talking about transaction, we have from Mark. He has this question about what transaction guarantees do they get with the Kafka integration? I think Kafka in general. Do you need to
sorry, could you repeat that?
What transactional guarantees do you get with the Kafka integration in Quarkus, I assume?
Oh,
do you need to ensure idempotence in payloads?
The second question is yes, but because it's actually the Kafka API is the Kafka protocol ensures that your producer is an idempotent producer for you to use the Kafka Transactions API. And the guarantees are somewhat limited. In the Transactions API, so this is actually a producer. So basically, Kafka Transactions is a way to produce some events for different topics, different partitions inside the same block. And if an error happens, it won't be committed. and if the transaction completes successfully, it will commit all the messages. And so these messages will be available for consumers that are consuming only the committed messages. So there's no like ACID like guarantees. There's no rollback action. The only thing that's happening is that the messages won't be committed. Some of the messages will be sent, and they will be visible for consumers that have read uncommitted isolation level, which is the default. But if you are using transactions when you're consuming them, you should have your consumers have the read committed isolation level as well. And
so basically, we expose all the levels that Kafka supports, right?
Yeah. And yeah, it's just important to stress out that these are not like database transactions at all. But we will be, and this is like of course experimental, and it's not even merged, so it's subject to change. And we will be doing some support also for exactly once processing on top of the transactions, so that let's say if you are consuming a Kafka record, you can start a transaction inside with the message, and at the end of the transaction, it will actually commit the offset. So this is what is known as exactly once processing in Kafka Broker. And maybe something that I will finish with. I'm already a bit on board. We actually also enable the mode in which you can also consume Kafka events as batches. So Kafka consumers they are using underlying like the Kafka clients API actually consumes records in batches. So we are exposing that directly to the application. And you can go ahead and consume events in batches, and actually you can go ahead and iterate on them, and maybe the outgoing doesn't make sense in here, and go ahead and let's say process the payload in here. So that's what I was going to show for today. Oh, maybe last thing that I forgot. I talked about the enabling Red Panda transactions, but we also enable a different Kafka Broker implementation for dev services. So you can go ahead and change the image name to a streams image, and we are actually only supporting the streams images for now, and it will create a streams image as a dev service instead of Red Panda. Let's say, I think it was it. Should also compile. Let's get rid of that.
So Mark comments. He was want to ask the one of questions. It's like exactly once would be very useful. Not sure.
Yeah, it's coming, and it's well, we will be exposing the API as experimental, of course, and I think it makes sense to use it with along with the batch support as well. Otherwise, it's the like. If for each consumed record the transaction is created, etc., it will be very, very consuming, time-consuming as in performance. Okay. And let's see.
So just be aware of time. We're on the half-hour mark now.
Yeah. Let's go to Loïc. I think he'll have much more interesting
So
stuff.
you said some of the stuff was in 2.8 CR1, and the latest here is coming in 2.9. Is that the?
Yeah, definitely.
Cool. Okay. Well, Loïc, let me turn off Ozan's screen. Got yours.
Yeah. No need to show my screen yet. Just
Okay.
so I'm Loïc Mathieu. I'm an IT consultant and a trainer from Zenica. I live in Lille, in France, and I contribute to multiple Quarkus extensions, MongoDB with Spanish, sometimes a little on Hibernate with Spanish, and some community extensions on Quarkus, Google Cloud Services extensions. And also, I forget about it, the Google Cloud Function extensions. And today we'll talk about a use case that I made with one of my colleagues, Victor Gallet, from Zenica also, but Zenica Lyon, about an application we built for Decathlon with small I reactive messaging Kafka. Victor Gallet, it's the one that created the code start of reactive messaging Kafka.
Yeah.
He contributed, and we will talk about our use case. So it's the application that we call VC Stream. We will talk about it at Devoxx France. So if there is some people going to Devoxx France, we'll talk about it also. So VC Stream, it's an application for the value chain of Decathlon, and it's an integration platform. The purpose is to stream data from the value chain of Decathlon to the other domain of Decathlon. Decathlon is a French retailer, but sports, everything about sport. Okay, so it's a big retailer, and it allows the application allows to stream data in and out of value chain, and so there is two process: the inbound process that will extract data and send them to the value chain, and the outbound process that will listen from the value chain. We connect to an ERP inside the value chain, and our slogan is one platform to connect them all, because the purpose is to connect to the ERP of value chain. So this is what is already done, but other system, and to connect to all external system of the value chain. You can show my screen now. I will show you a schema of our application. So this is VC Stream. So it connects to ERP module, and there is a listener that will listen from events, then send the events to a router, and the router will route to a dedicated topic that will, and then we have a validator that will validate the event and transform it to Avro and expose it to our partners' applications. We receive the event in JSON because it's easier for the ERP to generate them in JSON, and so we validate them later on with an Avro schema. So this is the outbound process, and today we also have a connector to connect directly to our Kafka an incoming Kafka topic for other applications that want to take advantage of our platform, because we offer some monitoring capability, observability, data resilience, data validation that are used by other applications than the ERP system. But the ERP system is our main data producer. And then we are also the capability to extract data from partner applications. So they have already data available on Kafka topics. So we extract them, then send them to a router that will then send the data to a sender component, and the sender component will transform the data in JSON and send them to the ERP module. Communication between the ERP module and the VS Stream platform, it's a proprietary protocol, and the rest is based on Kafka messages. So there is a Kafka topic between each component. Okay, so, and our platform is multi-module, so there is multiple ERP module. And so I think we have 20 components because we connect to 5 ERP modules at the time, and then we deploy everything on Kubernetes and on GCP. What is interesting with this platform is that we have some kind of a standard protocol exchange. So every time we need to add a new data, so every time the ERP module want to expose new data, or every time we want to extract a new data, it costs very little to develop, and all our platform is generic, and it's all our components mostly does nothing. I will show you some piece of code, but it's really everything is technical. So we just automatically convert JSON to Avro, or Avro to JSON. We automatically add routing rules. Also, we have what we call dispatching, so we can dispatch to multiple topics exposed to our partners. For example, saying for some based on some criteria, we will expose the data on topic by country, for example. So we have multiple rules, but we don't have a lot of business rules in our application. So every component don't do any I/O except to Kafka, and so we can take advantage of the reactive messaging framework at full speed, and we achieve 1 million events per minute per CPU and per gigabyte of RAM. So it's really a lot of events for very small resources. So here we took advantage of Quarkus, because we start our each component. Each instance of each component, we started with half CPU and half gigabyte of memory, and with half CPU, it can handle 500,000 events per minute. I will show you some code. So this is our typical example of what we have in our component. This is a router. It receives messages from a topic, and then it sends messages to another topic. So we use it's standard reactive messaging programmation, and basically it receives a message from the ERP, and then it will just route it to the correct topic, because the ERP use a single topic. Everything goes into each instance of the ERP send data into its own topic. Then we look at what type of data, and we send it to a dedicated topic. So it's really routing. And we just made some basic verification, like do we know this type of data? If we don't know it, we send it to the anomaly. Then we just manage some metadata around the message, some headers, and that's all. So this is really a component that just do nothing. almost nothing. This is why it's achieved a very high throughput. All our components are traced so via open tracing, and all our components generates metrics via microprofile metrics. So this is everything is started. This is very the kind of stuff we do. Okay. This one really does nothing. We have one component very interesting. With reactive messaging, we can use Mutiny. So Mutiny, this is a reactive type framework of Quarkus. And with Mutiny, we can do some more advanced stuff. And there is one component that do advanced stuff. As I said, we can handle a lot of events per minute. So 1 million per CPU. But usually we have in production, we have around today 50,000 message per minute to 200,000 message per minute. But we have some big spike of messages. So for example, sometimes there is some inits that just push more than I don't remember, but last time we made an init, we have 600 million events that was generated. So sometimes we have really a big number of events. And for the ERP, each time we send an event, there is a line in a single table for all type of events, and this table can so there is a huge impact on this table. And as the database is a shared database for the ERP, and it's a big ERP, it was causing too much query on the single table, so they asked us to group the message. And this was before message batching exists on Quarkus. And moreover, they want to group messaging, but saying, okay, if we handle 10 data types, we want a group of message to be on one data type. And for the sender, so the component that sends messages to the ERP system, there is a single topic on top of each sender. So we need to group the messages by type. So instead of using the standard message signature of microprofile reactive messaging, that is, I receive a message and I handle the message or produce another message, we receive a stream of messages. So we receive a multi, and we will return a stream of message, also a multi. So we'll receive a multi of Kafka records. So Kafka record, it's an object that describes a record of Kafka. And then we will group the stream of message by record, by a payload type, so by data type. Then we will group into list of 25, I think. This is the group. So we first group by the type of the event, so the data type. Then we group to a batch of 25 message for a maximum duration of I don't remember, but 30 seconds, I think, something like this. So this is very interesting. With Mutiny, we can do stuff very close to what you can do with Kafka Stream, but we don't need another framework. Just do it with Mutiny. Then we filter empty groups. I'm not sure it's necessary. And then for each group, so it's a group of at most 25 messages of the same type. And then for each group, we will just map it to another format and create a multi based on these items. So so this method takes a stream of Kafka records and will return a stream of message of a list of payload. Sure. A list of a message with a list of objects, but it's a single message with 25 objects, thanks to this instruction. Okay. So this is something a little complex, but it's very powerful. This is what I wanted to show you on this component. And the last component that I wanted to show you, it's our only component that does I/O. So this is a component that will receive one small event for each message. So each message that we handle, so each message that we extract from a Kafka topic and send to the ERP, or each message that we receive from the ERP and validate and send to a Kafka topic to be consumed by our consumer. Each message we will send a trace in our tracing database. So it's an Elasticsearch database, and then we have some reporting those inside Kubernetes, and this is used by our consumer to have some insight of the data inside of the messages that goes through the platform. So this trace message, we receive a lot of them, because for each message there is a trace that is emitted. And so first we handle the message one by one. So we index them one by one into Elasticsearch, and as indexing to Elasticsearch is an I/O to Elasticsearch, it's generally it cannot handle as many messages as the rest of the platform. So recently, we handle them by batch. So this is the experimental feature that Ozan showed you. So first, you need to configure the channel to handle messages by batch, and then we receive a list of trace. So here, it's not the same thing as what I show you inside our sender. Inside our sender, we have a message of list of or payloads. Excuse me. In the sender, we have a message with a list, and the list is the payload. Here, we receive a message with a list of payload. So this is I don't really like it, because it's confusing, because here, if I have a serializer of list of trace, this could be a method signature for a standard channel. But here I have a serializer for a trace, and this is a signature for batch consuming. Okay, we can discuss this later, Ozan, I think.
Yeah, definitely.
But okay, this is a little disturbing, because if you use Kafka record, you have the Kafka records object. But if you want to consume a batch of message, you don't have messages. Okay.
Yeah, that's true.
Yeah. So by just consuming a list of trace, a batch of trace, not trace one by one, then we can use a bulk request. Bulk request is to Elasticsearch a way to send a bulk of commands. So here a bulk of indexation, and this drastically reduce the I/O on the Elasticsearch server. It's reduced I/O by 4, I think, on our standard message on our standard output, and when we receive a peak of messages, it will go up to the port size of Kafka, and port size of Kafka is 500, so we will create bulk of 500 messages, and this will reduce the I/O on Elasticsearch a lot more. So this is really, this is really cool. And as there is a reactive Elasticsearch client, everything goes integrates smoothly with reactive messaging.
That's very cool. Yeah. By the way, you can use, instead of message of lists in your incoming type, you can use Kafka record batch of like key type and trace. That should maybe alleviate your problem.
Yeah,
we can take it offline if you want.
We sometimes use message, sometimes you use Kafka record in our different components. There is not really reasons why we do this. I think we start working with it more than 1 year and a half. So not all our components uses the same method signature. Okay.
Great.
So I talk about the way we handle a lot of messages. We can do this because our components are mostly technical, that do no I/O except for the tracer, and that don't have complex business rules. But we also are able to achieve this because we monitor everything. We have a lot of matter. We use Prometheus and Grafana, and we test from time to time the performance of our application. So we have a lot test. We use Gatling to generate load on the application, so we can simulate the load from the ERP via an HTTP endpoint. So we have a mock that allows us to inject a message inside our outgoing process. And we also have we use also Kafka Gatling library to generate load from an incoming topic. So we do a lot of benchmarking experiment, and we sometimes found some performance issue that we discussed with the community. I remember when we migrated to Quarkus 2, we found some performance issues thanks to assign profiler. So I use assign profiler to generate performance profile with flame graph. So to all the people that listen to us, really, if you feel that there is some performance issue, on Quarkus we have a page that explains how to take profiling information, performance profiling information, so you can gather them and then just get in touch with the community, and we can help you. Okay, I don't know if there is some questions.
I was actually going to ask you about the performance benchmarking, that you already discussed that out. Like these are all microservices, and they are running in JVM mode or native mode in your
GCP
so cluster?
Effectively there is here you see only 6 components, and some components are multiple instances, like the listener and the sender, that there is two more components to manage, 2 AECs to manage anomaly, and everything is separate microservice with only one that only do one thing. so we can scale them independently. Recently, we incorporate KEDA. This is a tool to make some advanced auto-scaling in Kubernetes. And we will soon have everything that scale automatically based on Kafka consumer lag. This will be really cool. And everything is deployed inside the JVM. So we don't do native because the ERP, we can communicate with him with proprietary protocol that used native library, and native image in native library. It's not easy. And I know very well the JVM, so I prefer to deploy on it. But it's still on the roadmap to test it.
And how are you handling the commits on Kafka topics? And are there any tips that you can give us, or?
So we use the throttled commit strategy. This is very important to have high performance application, because with the throttled commit strategy, reactive messaging will not commit each offset, but will commit the offset in batch. So basically, it will commit every I don't know 1,000 offset or stuff like this, depending on the throughput of the application. And we don't have any blocking methods, and we try to use mutiny when we need to do some more complex stuff, like with the standard on the tracer. So everything is every message is handled inside the event loop. We also have one. This is the other router. Yes. Yeah. We also have this component that receive one message. So when we extract a message from an external topic, sometimes we need to route it to multiple ERP instance. And here also we use the capacity of the integration of reactive messaging and mutiny. So we receive a single event, a single message, and we return a stream of message. And this also is very performant. Our first implementation was using an emitter. Like you show, an emitter is usually used from an HTTP endpoint to bridge synchronous API with asynchronous API, so to bridge imperatives to reactive style programming. And here, as reactive messaging, everything is reactive. So when my method receive a Kafka record, it receives it inside, in fact, a reactive process. So it was more performant to return a multi of message instead of using an emitter and sending 2 or 3 messages inside the emitter.
Yeah.
But here we lack transactional support because it didn't exist. So I hope that in the future, when we have an incoming and an outgoing, we can just configure them to be inside a single Kafka transaction. Because here, if we we don't have.
I am thinking about it, but it wasn't easy to make it happen. I think the next release will include the transactional support on emitters, and I'm thinking about how to resolve the problem that you're talking about. because it's fairly difficult to discern when the transaction starts and when it finishes with this kind of pattern. Because everything goes into a stream, you need to make sure that at some point your transaction starts, your Kafka transaction starts and sends the events, and at some point it will finish. That's the challenge. But we can maybe discuss around if you have any ideas on that.
Yeah, that's why we create an unique identifier for all our message. And so we just we always take all our consumer to be idempotent, because today there is some risk of message duplication in our platform.
Yeah, I see. And the unique identifier that you are creating is also used in Trace, right?
Yeah, we use it everywhere. We log it, we send it to our tracing system. We add it to open tracing. We put it everywhere, and then we the first component of our platform, so the listener from the for the messages that are coming from the ERP, or the extractor for the messages we extract from our external broker. The first component will create the unique ID, put it inside the header, and then all the other components will just transfer it. Just basic. I think it's just basic best practices.
Yeah. I had a question around the dev tools and how are you using them, and like if you have any extensions on it.
So we don't really we start before dev services. So we don't use dev services. We have our own test resource. Not this one. I love plain unit test. So I use unit tests with no I create unit tests that don't start Quarkus. This is an example of unit tests that don't start Quarkus. I just mock everything. Okay, this is our unit test, and we have integration test. So integration test we start Quarkus, and we use our own Kafka container test resource that will start Kafka Broker and schema registry.
Okay, so your Maven unit tests, Surefire unit tests, they are like true units, like don't run
plain unit test.
And then you are using failsafe or just
and then we use failsafe, or maybe it's Surefire configured for the integration test goal, but it's the same. So we use the integration test goal of Maven to launch our integration test script suite, and this one will start Quarkus and start a broker and schema registry. But we plan to investigate test dev services support because it could be easier. But today, sometimes on our local environment, we'll start multiple components, and we have Docker compose that will that start broker, schema registry, Kafka HQ to have GUI on top of Kafka. We start an Elasticsearch server, so we use Docker compose. So dev services for Quarkus Dev is not, it's not what we want. And for test, we think about it because it can be easier for us to migrate to what is inside Quarkus. And I'm also want to test the new Kafka companion support because it seems to be very, very cool. Today we use awaitability, but we also use raw Kafka producer and consumer. It's not very easy to use. So we plan to investigate Kafka companion.
Perfect.
And we also have end-to-end testing. with Kafka, with Karate. I don't know if you know Karate. It's an end-to-end testing framework for API, and we have the same. This can be. This
But
can be
you're just using that on the REST, on your REST endpoint. You using Karate on the.
No. We used. I will show you because it's I don't know if a lot of people already did this. So Karate is usually used to test API.
Yeah.
But there is also a Kafka integration when you can ask Karate to extract to send a message to a broker or to listen to a broker, and we use this to have a full end-to-end testing suite. So basically, when we merge a pair to develop, we will deploy to a Kubernetes cluster. And we will launch our end-to-end test suite. And this is so this is Karate. So this is the Gherkin. So we say, okay, given a Kafka producer, given a message, we have a test fixture that with test messages and a UID. When I send the message to a topic, then I can check that. Here it uses another when, but okay. And when we search in Elasticsearch a trace for this message, then I have a response for Elasticsearch, and I can assert that the message was type postlog, and the status of the message was okay, and the message has been handled by the postlog extractor and has arrived to the FNR instance of our ERP. Yeah, so we have tests like this for the inbound. So when we extract from Kafka topic and send it to the ERP, and for the outbound, so when we receive a message from the ERP and send it to our broker. And for the outbound, we have mock endpoints. So this is really an endpoint. So this is more traditional Karate scenario. So you say when you call the /mock/stock pictures URL with request, this is our payload, and key. This is a parameter to pass a key to the message. So our scenario, then we have a status 200. So then the message is successfully sent to VC stream. Then we say given the UID, this is a response of our mock. So the mock respond the UID of the message, and then we can again access our Elasticsearch server to check that there is a trace for this exchange.
Okay, so it's like an indirect thing. So you have to have, you do the Kafka request, but you do the assertion by looking in Elasticsearch picked up the right thing.
Yeah. So first so yes, for inbound we use a Kafka producer and check on the Elasticsearch, and for the outbound we use a mock and search on Elasticsearch. Before searching to Elasticsearch, we use Kafka consumer, but it's not very. It creates a lot of false positive because Karate is just able to wait some time, and there is in Kafka API is a lot of there is a lot of asynchronicity in the Kafka API. So usually it can be possible that you consume two too late, so you miss a message, or there is too many wait due to Kafka polling mechanisms. So there is too many false positives. So we decided to check on the Elasticsearch only. So there is not a lot of Kafka specific stuff here.
Yeah. No, I like Karate. Like it has a nice, it's a bit weird in places, but it's lets you decouple with for learners. I didn't realize the Kafka one was weird, but that makes sense. Cool.
Yeah.
Okay, we are 10 minutes over time, so we should thank you for this one. And I said, so we got some new stuff. It's already in 2.8. The Kafka Companion is coming in 2.9 or something.
No, Kafka Companion is on 2.8 and transactions will be on 2.9, I think.
Sorry.
If everything goes well.
Yeah.
And for the roadmap, I think I can say 2 words like we will be, I think we will be developing a dev UI integration for like Kafka operations in general, some basic stuff for the start. And also a way to handle offsets in outside of Kafka, like a kind of a state management with offsets. What will be calling checkpointing. That will be coming in the next releases.
Cool. And Loïc shows that even though you don't have all the nice features, you can still build something with it. So yeah, awesome. Thank you, and we'll say enough for today. And next week, hopefully at the right time, at the right place, daylight same time, we should be fixed then. But yeah,